Okay, I'm going to do a couple of demonstrations here and some motors. We're going to take some common start and run and check for grounds, use a megger and various things like that. I want to start here with this compressor. And this just, first of all, check and see if it's got any grounds. Now, a ground and a short are a little different, right? A ground is something with the electrical touching the frame, the case. A short can be winding to winding that doesn't necessarily trip the breaker, but causes the motor to run hot or such. So the first thing we're going to use is the megger. And what the megger does is it really tests the insulation of the motor to see if the insulation's good. And it's a kind of a pass or fail or a caution. It's a very good tool for customers because if they have a bad motor, I'll show you what it would say. If they have a bad motor, they're going to get a red, and the red says bad. If there's something going bad with the motor, it's going to give them a caution or various degrees of caution. If the motor's fine, it's just going to run off the scale and just go all the way down. So this is one of those kind of tools that you can tell a customer you have a motor that's going out, and you can show them, and it won't be you interpreting an ohms reading. So we'll take a couple of readings. I don't suspect that these are good or bad. I don't really know. But we'll check them and see. Now with the megger, you don't touch the leads. Meggers put out between 500 and 1,000 volts. If I touch the leads and push the button, it's going to hurt. So the whole point of the megger is to put a lot of voltage into the windings and then check and see if any of that voltage is coming back to the case. So that being said, that means these are magnetic, if I put it on the paint, it's going to tell me it's good because it can't read through the paint. I have to find somewhere on the motor that there's no paint. I've scratched the paint off on the frame, so I'm going to check it there. Let me hook it up to one winding, make sure nothing's touching. Push the button, it just runs off the scale. So that winding is not grounded. I'll check the next one. Kind of the same thing there. That winding is not grounded. I can check the final one. Same kind of thing. It just runs off the scale. That means that this megger is seeing nothing on this motor from winding to ground. That doesn't mean the motor's not still shorted out. Now, to figure that out, I have to use a regular ohm meter. I can take the ohm meter, I can put it on ohms, which is the horseshoe looking emblem. If I find a ground, it's going to give me a beep. I can turn that off, and I can just see it without hearing it. Now with the ohm meter, what I'm looking for is across the windings. I'm looking for the windings to have some resistance, because what if I'm trying to figure out common start run? What if I need to know? What if I don't know which of these is common, which is start, and which is run? I can take some readings. Now, before I start, I have to make a baseline, and I've got a red and a black and a yellow. So let me come over here to the wall. And let's just write that down. We've got a black and a red and a yellow. Doesn't matter how we write them, any of that. We just got to get that down. So we're going to take our first reading, and just take a reading between, say, red and yellow. Put the leads in here. It's very important that I don't touch these leads with my hands, not because I'm going to get shocked, but because I'll throw off the reading. So I'm getting a reading of 3.8. So between red and yellow, 3.8. So I'll write that between them. 3.8. Okay. So let me check between red and black. Uh, 2.5. So between red and black, 2.5. Okay, now all that's left is to check between black and yellow. And I can do that. And I'm getting 1.5. So, all right, so here's what we do next. This is what we know. We know that we have the big number, and typically if the two small numbers add up very closely to the big number, the motor's probably okay electrically. And that's kind of what you get. 2.5 plus 1.5, that's 4. That's very close to this number. So that means in our world, what we're going to know is we're going to look at this big number, and we're going to say we know the biggest number points to common. So we're going to kind of look across here, and we're going to say, okay, we know black is common. So just put a C right there. Now what that just told us is this biggest number came because we read between here and here and here. So we kind of have the motor is kind of shaped like that. We can actually get rid of this. We don't need that anymore. Now we have two numbers. We have a bigger number and we have a littler number. On a compressor, it takes more to start it than to run it. So we know this is going to be start and this is going to be run. So we've just found common start and run just by taking some readings, and I can pretty much tell you the motor's not grounded, the windings add up. Unless there's a mechanical problem, that compressor's probably okay, right? So that would be, I would say that compressor's probably good. This compressor here, a little different. We won't check everything the same way, but this just take a common start and run, just kind of a brief reading and see what we get. If I check between blue, and I've got alligator clips, which are really your best friend anytime you're checking ohms because they don't slide around. There we go. Here. And let's do blue and red. So I'm getting 10. So between blue and red, I get 10. Between blue and brown, I get 12. So there's a bigger one. And let's see. Let's do red and brown. I get 12. So those are not adding up. There would be a good possibility this motor is burned out, and that's probably why it's here. It's probably bad. If the windings don't add up, unless it's a three-phase motor, if it's a three-phase motor, they will all be the same. If it's not a three-phase motor, they should always be a high number, and then there should be two other numbers that add up to that high number, always. Let's look at a fan motor. We've got a couple of fan motors here. These are both condenser motors. You can kind of tell by looking at them, they've got this rust mark around the band here. This one's getting kind of old. These are the kind of motors that just by looking at them, I would be offering the customer a new motor. This motor's not long for this world. It's been hot long enough to burn the paint off. It's probably not going to last a long time. Mechanically, they don't feel like they're bad. Just see what they look like electrically. We're going to meg these with the megger. I have to find a place, remember, where the megger can get a good bite. Just try that screw, and just to check it, I'll check the other screw. I should get a bad reading, and I do. That's just because I know that I got a good ground. Now just take the wires and see what we got. There's one. Okay, not reading anything on that one, so that's okay. Let's check the brown one. Same thing, just kind of running off the scale. Same thing here, just running off the scale. Let's check the red one finally. Okay, so there's no ground on this motor. So the motor could be okay, it was replaced because it's old, or it could be some other reason. It just came out of a unit that got scrapped. The megger is a tool, it's a must-have tool. You gotta have it. It will do things your meter can't. Remember your normal volt ohm meter, it reads ohms just fine, it reads volts just fine. It doesn't test for meg, it doesn't test for insulation. And that's really what the megger is. It's an insulation tester, right? So we can move over here, and I'm going to show you this demonstration on this fan, because in the HVAC world, we can always get a motor. We can go to any supply house, we can get a universal motor, we can always get the motor. What we can't get most of the times is the fan blade. Okay, we can't get the blade. Sometimes we can't find a blower. So we need to be using a hub puller a lot. Now this one happens to be loose, but what I want to tell you is a lot of times y'all are out there and you're seeing these motors and the motor's dead and there's 3 or 4 inches of rusty, nasty shaft. And I've seen lots of people go out and they try to take their hammers and their pliers and their tools and they try to pull that blade off of that rusty shaft. You're never going to get it, and chances are you're going to ruin the blade along the way. I've seen many guys at the supply houses with these motors just like this. They just threw it in the back of their truck and got to the supply house. By the time they got there, the motor's bent up, the blades are bent up, they're ruined. in the field while you're at the house or the place of business. Get your puller out, cut the shaft off with a right angle grinder if you have to get it close to the hub, and then use your puller to pull that off. It's such a simple device. I mean, it is what it is. They call it a hub puller, and it's exactly what it does. It bites into the hub. When you put it on and you tighten these down, it's going to bite a hold of the hub, so it's putting no pressure on the blade. Mechanical advantage, when I turn this in, it's going to just pull that off so nice and easy. I'll have no problem. I'll never damage another condenser fan blade if I use this $150, $60 tool. It's such a worthwhile thing. I think everybody ought to have it. We can also use that same exact tool on the blowers. This is another thing that we take off quite a bit, and that hub puller will fit right here. It'll help pull that off. We don't have to be hammering on it or beating on it. We can easily get the hub puller in there and use mechanical advantage to push that motor out. This blower happens to have an ECM motor on it. And they're new and they're nice, but they also don't last quite as long as the older PSC motors did. So that's the demonstration on these motors and how to test them, and just kind of a quick overview.